This is an AMD BC250. It was originally built to mine cryptocurrency, not to play games, not to emulate retro consoles, and definitely not to sit underneath your TV. But today, we're gonna change that. We're taking this forgotten piece of crypto e-waste and turning it into a fully functional Steam gaming console. In this video, I'm gonna show you every step, from the custom 3D printed case and cooling, to the BIOS update, Bazzite installation, unlocking all the GPU compute units, and unlocking all the CPU cores that this board has to offer. By the end, you'll have everything you need to build your own BC250 Steam machine from scratch. Let's get started. The first thing we need to do is get this heatsink off the board and take a look at the thermal paste and everything that's going on under there and make sure that it's in good shape. We're probably going to replace the paste. We're definitely going to replace the paste on the main GPU. And then there's also thermal pads that are used underneath here. We'll take a look at those, see if they're in good shape, and see what we need to do to get this thing rolling. To start that process, we need to remove these back screws here and get this back plate separated from the heatsink. And then we're gonna apply some heat to the heatsink and we're gonna pry that off very carefully. You know, when I use the word pry, I mean, you know, very, very carefully. We're gonna just apply heat to loosen up the thermal paste and then give it a little twist with a plastic tool and get it out of there. Once we have everything off, we can take a look at the thermal pads and the paste that's here. The thermal pads on this board aren't in horrible shape. They could probably stand to be replaced, but I'll probably tackle that in the future. I am going to clean off the paste that's on here and replace it with some Arctic Silver. Using a combination of plastic scraper tools, Q-tips, plenty of alcohol, it breaks it down pretty easy, gets it all cleaned up, and gets the board ready for the new paste. Applying the new paste is pretty easy. I put a little dab in the middle, and then I like to use a spreader tool to spread it out. Some people will tell you you just need a dot, you make an X, you do it. There's a lot of different theories on what's the best way to do this. For my money, I like to put a little bit on, spread it out, make sure I get a nice clean coat on there, everything's coated, and then the pressure of the heatsink will spread everything out the way it needs to be. This ensures I don't use too much, I don't use too little. Then we can put the heatsink back on. It's the reverse of the disassembly process. We just reattach these screws and get everything sort of torqued down together. Don't over tighten these screws, and don't tighten any one screw too much until you have them all started. All right, this next step, there's some debate kind of out there on this step, whether it's necessary or not. We're gonna take a look at the heatsink that's installed here. Let me see if I can get you a good view. Maybe this side will be better. Yeah. So I'm gonna see if I can get you a kind of a decent view here. Let me see if I can zoom into that. All right. So the heat sinks themselves, it's aluminum fins that run down the entire path of heatsink. And then the tops of the fins are actually folded over on top of the next fin, so that it makes kind of like this chamber. Because the way these were cooled in the server was usually there were like small fans here sort of in the front of the server that would push air and force air down out the back of the case. But for our case, we're not going to have that fan bank that sits up here on this side. So really what we want to do is we want to come up with a way to get air running down that same path, but not, but with more surface area than this. So what we're going to do, and there's a few different methods. There's a lot of methods online, and I'm going to show you the method I used. I don't know that it's the best one, but it's what ended up working for me. We're actually going to use a scooper tool. It's another 3D print that you can find on Maker World, and it's actually straightens out the fins and sort of bends the folded over part up. One other technique I've seen is people actually just push the folded part down. I don't know that I like this that much because it will interrupt the airflow. And then the other technique I've found since doing mine is I've actually found where they actually cut the folded over part off. They use like pliers, and they actually just sort of slice off the top part, so it just leaves a nice clean. And I think if I do another one, which this is a spare board, this is a second board that I have. I think if I do another one, I might end up doing it that method. But I wanted to show you kind of what I went through with this process, and I do think it helped my thermals. I don't think it helped me enough. I think what we're gonna find, spoiler alert, I think what we're gonna find is I think there's some other things I can do to help the cooling here, including those thermal pads that I didn't replace, and then maybe doing some other things with the heatsink and incorporating a couple more fans as well. But you can go nuts on this. Sky's the limit. I've seen people put water blocks. They've actually worked out water block mounting to the GPU, so you can really go nuts with it. But for today, with the case that I have linked, I'm going to show you the process I did, and then you guys can decide how you want to test it. You could totally just run it as it is and set a fan directly blowing onto this, or incorporate fans down here and do your own testing. Do your own thermals and see what they look like and what you're happy with. But to start off, we're going to get these started. We're going to pry up the back side of the heatsink, and I 3D printed a scooping tool, which I'm gonna have the link for that. All the links for everything's down in the description. So I'm gonna use this scooping tool, and I'm gonna pull up. I'm basically going to bend up the first few sections of the heatsink. I'm going to incorporate this other heatsink that I got off Amazon, which the case designer actually recommended this, the air scoop that they have. This fits in there rather well, so it'll be good because it sort of directs the air into the direction you need through the fins. But I also want it, I want a little more surface area than just there on the end. Getting started with these fins, I used a couple different things. I used an X-Acto knife. I used a flathead screwdriver. I used the scooper tool itself. I used small pliers. I did a lot of different things, and it was kind of a pain to get started. But once I got them running, the scooper tool actually did its job. This is the tool's sort of modded off of another tool used to straighten out the radiator fins of like an HVAC condenser, or like a heat pump condenser outside your house for your AC. But it works really well here. It works well not to get it started, but to once they are started, kind of runs down through, and you'll kind of see once I get them rolling, it does literally just scoop through and get everything coming down. There were a couple of these that I ended up just peeling off the folded part, and I think that's where I really liked the concept of just cutting off the top side of that. I think it would make it a little bit easier, and definitely it would come out a little bit cleaner when it was all done. But after a lot of working and trying, I finally got it to where the scooper tool was getting in there, and I could just sort of drag it down across the fins, and it would bend it up, and then I could come back with a like I said, pair of pliers or a screwdriver, and sort of straighten all the fins out the best I could. As I ran into parts that were just mangled or bent, I would pull those off. I would just try to get those out of there for a couple reasons. One, I didn't want any sharp edges, and two, you know, every little thing will block and hurt your airflow. So trying to keep it as level and as straight and as even as possible really will help with your airflow. How much? That's to be seen. We need to do some testing on that. And this section is the only section that I'm gonna do here. I think this will be enough. Some people do that lower section down on the bottom side of the board, and I'm not gonna mess with that. I'm just gonna leave that as it is, and then I'm going to, like I said, hook that other heatsink there on top. But what I really want to do is just try to bend these out and get them as straight as possible, and then any you know, small pieces that are sticking up, try to either fold those down or get them out of the way to help with airflow. And this is kind of what I came up with. It did stay pretty straight. I did go through and clean up a little bit more just to try to make sure that nothing was in the way. But the scooper tool really, once things got started, it did a really good job of getting everything straight and turned the right way to catch as much air as possible. All right, once I have my fins all set up, I'm going to install the shroud. The shroud's part of the case print, and man, it's designed very well. This fan fits perfectly on it. No realignment was necessary. It's going to sort of sit inside the side of the case. It's going to have a you know, basically just drawing air in there as much as it can. Those holes on the back are for that back heat plate, for cooling on that side. Printed this whole thing in PCTG. I think PCTG is definitely probably the best material to use here. It resists the thermal shifts that we're gonna have, and it's just, man, it prints so nice. It's awesome. When I was straightening up my fins, I did get a wire brush in there to try to get everything as cleaned up and straight as I can. I think it did a pretty good job. There's a couple parts where it could be better, but I think it's going to, with the scoop of the shroud, it's going to actually push air in the right direction. So it's going to give us a really good, you know, flow in the right direction, I think. When it slides over the back of the case, so the tab flips over there, that back PCB, and then the front two these front two ears clip over the PCB. And once it's in place, it fits really good. Once it's in place, you can kind of see this path that's being created here. That gap is there for the heatsink that we're going to add on top, just as extra cooling directly over the GPU, and then that'll push airflow completely through. The case designer said that this was, you know, this is where they got their best cooling. So this is the first one I go with. This might change over time, but I thought it was a good compact design that we could test out here. So it is an adhesive thermal pad that goes on there, so we need to clean up the heatsink that's there. I've been handling this a lot, so I got a lot of oils for my hand. I want to get some alcohol and just clean it up. Be careful here, because there probably are some sharp parts from where we've been bending the heatsink around. So just be careful, be knowledgeable. If you see any high spots, you can use anything to sort of flatten that out, just to make sure that the adhesive for the new heatsink, the new thermal pad, makes a good connection and sits down on there. And once you get on there, you just adhere it down. Now make sure your orientation, you know, we want those fins going horizontally because we want the airflow to run through the fins. We don't want the airflow to run into the flat side of those fins. So this orientation that I have here, this is the exact orientation that you want when you install yours. And that's really it. You know, everything's together. We're pretty much ready to fire it up right here. I'm probably gonna assemble at least the back half of the case. That'll help me, or I'm sorry, the front half of the case. That'll help me just stand it up and get ready for testing and things like that. But yeah, I think we're ready to go here.
This is the power switch for the system. And this power switch
goes to my power supply. Let me get my power supply. Okay, so it goes to my power supply, and I've got a graphic put together so you can see. This power switch needs to go to 2 pins on P14. The 2 pins that I'm using are, it's labeled on the connector. So the 2 pins that I am using, see if I can find, oh, they're labeled back here, are 14 and 8. So 14 is your power supply on signal, and 8 is your common or ground signal. So what I did to keep everything clean is I just cut the other lines. We don't need any of the other lines because then we're going to use the GPU cable, like the PCI power cable from this to power the blade. So I just kept these on here. Now, one thing you could do if you wanted to add LEDs, if you had other accessory fans. So for my fan power routing, there's actually a CPU fan on this board. And one of the reasons I really love this Arctic fan is it comes with a daisy chain. And this daisy chain is going to be actually perfect for what we're trying to do, because my Noctua fans, NFA4X20s, they actually come with splitter extensions and stuff like that. So I'm going to have 2 of these mounted. Basically, these 2 are going to be mounted inside the case on the back here and here, again, to pull the hot air out. Yeah, so that's going to take care of all of that. So let's see. With that, I need to wire up power supply. I wasn't going to use any of these, so I just cut them all off, put some heat shrink over the end. Now, I left myself a little bit because one of these days maybe I do want to add LEDs or do something cool. I don't know. There's a lot of opportunities here because none of these lines are being used. So all the 5 volt and 12 volt that you need. All right, let's see what else. Okay, so what I'm going to do, I'm going to use this as kind of like my measuring surface. Power supply back in here. All right, it does, man. It's a really well-designed case, so props to who designed it. That's going to work really well. But the idea is that these 2 are going to snap together, and basically the board itself is going to kind of help hold everything together. So this is going to be sitting right here, like this, and I need these 2 lines here, and my power switch, which again, everything you use in the description, power switch will be, mounted right here. What I'm going to do is I'm going to solder this up. I want to leave myself plenty of slack. I don't mind having some extra slack down the bottom of the case, because if it's too tight, we'll never be able to take it apart. I'm not going to use quick disconnects. I'm just basically going to, when I need to take it apart, I'm just going to disconnect at the power supply there like that. So I'm going to attach this in the case, get it secured, solder these up, cover it up with some heat shrink, and then I think I'm going to put together this front half of the case. I'm going to go ahead and install the board and get that set up. So the way this case works, let me see if I can show you a better angle. All right, this back plate here, so it sits off the board. You can see here it sort of sits back from the PCB just a little bit. This plate here is actually what slides into, it slides into rails right here on the case, this rail here and this rail here. So it's going to basically slide in right there, and that's going to be what holds it in place as we're doing our work here. All right. Let's see. One other thing I want to do. I want to go ahead and put that. I'm going to put this splitter on. I'm going to pull this little sticker off. Go ahead and put this splitter on now, so that, all right. Go ahead and put the splitter on now so it's easier to get to all the cable management and everything. Yeah, once we get it all together. All right, all that looks good. All that is set. Get the soldering out of the way. Let's slide this bad boy together. All right. Kind of a friction fit, which is good. We definitely don't want it going anywhere. There we go. Yep. Oh yeah. Oh that went together nicely. Okay. All right, that's it. There we go. Okay, that's not bad. All right, so there's the fan input. Been pretty good. I think we're all the way flush to the front of the case. It looks like it. Let me see if I can. Yep, that looks pretty good. All right, this is our power for the blade itself, our two fan connectors, and power from our switch to go to the power supply. We're not going to hook these other two fans up till we get the back half of the case done, but now I can actually set this up and power it up and get to configuring it. So I'm going to move my power supply over here. I'm cleaning off my bench a little bit, kind of make a little bit of room, and then hook up the power supply and get it ready to fire up. So before I put everything together, which I got a little overzealous yesterday, just a little bit, I'm going to go ahead and do the BIOS update process now. All right, the link for the BIOS files will be in my description. We come here, we select download. It's going to tell you, because it has the word BIOS in it, Chrome doesn't like that. Go ahead and download it. These files actually came from one of the original people that started working on this project. YouTube name Old Lamer. Pretty awesome guy, has really dove into the depths of benchmarking and testing and performance analysis and things like that. And it has been a really great process to follow. So my video is going to get pretty specific as to what I plan to do with the system. But if you want more general knowledge or more ideas or possibilities, definitely look up his YouTube. I'm going to have it down in the comments below. Once your files are downloaded, we're going to need a USB drive. Make sure the USB drive's empty and format it. We're going to format it in FAT32. Once that's complete, extract the BIOS files and take the contents of those BIOS files, move them to the root of the USB drive. There are two versions of the same BIOS. You'll see there's BC250.ROM and BC250-Steam.ROM. And that's, again, Lamer kind of came up with it's pretty awesome. It's got the Steam logo when you boot it up. So only difference between the two. I'm probably going to go the one without, just to keep things clean and simple, but pretty awesome that you can actually modify that. So maybe that's something we can do. Maybe we can get the Video Game More logo in there one day or something. See how it goes. All right. Once your USB drive is set up, we're going to eject it from the machine, insert it into the BC250. Have my USB stick, USB drive with all the BIOS info, and then we let it go ahead and boot up into the UEFI. There's an EFI big on the drive. It's part of the package that you downloaded. And then here we need to go to FS0. It looks like this looks like USB. This looks like it's going to be my drive. So we just go FS0. Sorry, FS0 colon, boom. dir, check the directory, and yes, this is our drive. These are all the files that we just set up. If you happen to be in a different one, let's try this. So if you happen to end up in FS1, there isn't an F. So I guess if you do have a drive installed and the drive does have data on it, it could show up as a possible place for things. So you could have multiple options. For me, it's a blank drive. The only thing I have is this USB drive, so we're good to go. All right, just to be sure, dir directory, it brings up everything that's there. All right, and then the first thing we're going to do is we're going to make a backup of our current BIOS that's on there, because if anything messes up, I want to be able to roll back to it. So we're going to run the green command there, the AFUEFI. So you can just start typing A and then hit tab and it'll fill in for you. And actually, if we hit enter now, it will actually give you a list of commands and options. And these are some of the commands and options that we're going to use. You can enter again, it'll kind of go through everything, show you what it is. So what we're going to do is I'm going to make a backup. And so I'm going to name it, so it's command, then name of the file. So I'm going to go with OG BIOS backup, ROM, and then /O is the command to do it. So it's going to read from the machine BIOS. It's going to write that file on my USB stick. So if anything goes wrong, or if I ever want to roll back to it, I have it. Okay, once that completes, we're going to run the same command, well, similar command again. This time we're going to install new BIOS. And remember, I'm not using the one with the Steam logo right now. I'm just going to do the basic BC250. And the commands for this are /p /n. Oops. Held the shift key down a little too long. So spaces in between every block of function. You have the program, the file, and then the action, what we're doing. So at this point, I'm going to enter and it's going to start flashing. If you lose power in the middle of doing this, it will brick your board. It will brick your board. There's no way to recover from it. It is not great. So don't do it in a thunderstorm. If you've got an ups, do it on an ups. Yeah, just be careful. Don't let the power get disrupted. It's a quick process, but do be careful. So this BIOS that we're installing, I'm I've kind of listened to a couple of different people in the community. Some people go with version 3 of the BIOS, some people go with version 5. Old Lamer goes with version 3, and his reasoning for going with version 3 is actually very good and is something I agree with. Version 3 unlocks some of the options of the BIOS. It doesn't unlock every possible option of the BIOS. Version 5, apparently there's a version 5 out there that unlocks all kinds of extra things that you could do. I'm not using version 5, I'm using version 3 because really the only thing we need to do is adjust our VRAM. We don't need to do anything else inside the BIOS. Everything else can be done inside the software once we're in the operating system environment. All right, with that all done, we're going to shut down the system. And you can do this lower button back here on the back. The top one, the blue one lit here, is reset, and the lower one is to power it off. We're going to power it off. So I'm going to remove the USB drive. Again, do this before hooking everything up like I did. Don't be a dummy. I guess that's why we watch YouTube videos, right? All right. This jumper right here in the middle, clear CMOS, I'm moving it over to the right. Let me get this a little closer for you to see. All right. I've installed it on the right pins, the pins that are closest there next to the CMOS battery. And we're going to let it sit there for probably just now is long enough. That breaks the connection from the battery. It's just like taking out the battery. It's the same concept. Breaks the connection from the battery so that it has time to clear out its memory. And then I'm going to move it back. Don't forget to move it back. Otherwise, any changes that you make in your BIOS will never be saved. All right. And then one last time, with it set up here the way it is. Oh, lower button here. I hit the top button. Lower button here on the back. Power button. And let's see if we can get into this BIOS. That was a good sign. All right, there you go. You see at the top. So we have NBIO. Common option. This is the only section that we're going to be changing. So we go down into GFX graphics configuration, and we go into UMA frame buffer size. You can set this to different things. People have been experimenting. So the default setting, the default split between your RAM and your VRAM is 7 gig. So it's a 16 gig card, so you get 9 and 7. The split that I'm reading is the best is 4 gig, although I have heard some people have gone all the way down to 512 and got some really awesome performance gains from it. I'm gonna start with 4 gig and see how it acts for me. This might be something we come back to in the future and we do some experimenting with to see if we can squeeze a few more frames out of it, see how hard we can really push this thing. So I'm going to set it to 4G. I'm going to hit F10. F10 is the command to save your configuration and exit. And we're going to reboot. I'm going to go back into BIOS one more time just to make sure that it actually saved. Yep, and it did. All right. Now at this point, our BIOS update's done. Everything that we need outside of the operating system environment is done. It's time to go ahead and install that operating system. Now we're going to use, we want to install Bazzite. Bazzite's going to be our operating system. We're going to use Etcher to do it. If you need to download Etcher, I'll have the links in the description. Bazzite link in the description. All the links will be in the description. Yeah, so Bazzite, we're going to download Bazzite. We're going to do the desktop version. We are going to be using an AMD GPU, and I'm going to do KDE, which is like SteamOS, and I'm going to tell it that I want it to go directly into Steam gaming mode. So what I'm basically building this to be like a Steam machine in my living room. So I do want it to go directly in this. Now, for a lot of the development and things like that, we're going to get out of it and go into desktop. So, you know, you could do a traditional desktop experience here if you were wanting to, you know, experiment a little bit or whatever, but that's fine. And then right here under new users, just hit download Bazzite deck. We'll download an ISO. ISO is here. Now we're going to Etcher. All right, flash from file. Boom. Select target. Boom. Select one and flash it. This is going to take a little while. We'll check back in when it's done. Okay, while Etcher is finishing up, I'm going to finish the backside of the case by installing the couple Noctua fans and a power supply, and then maybe we can just go ahead and put this thing together and start using it in its case. How cool would that be? I'm gonna start with the fans. Most fans will show you a direction. You can test them. For the most part, I think most of them blow towards the guard. No, I think the bearing. I don't know. I never trust it. So I love when fans actually have marked airflow and turn speed or turn direction. They got turn direction and airflow, those two arrows. So we want this as an exhaust fan. So we want it exhausting out the back of the case. So we're going to mount our fan like this inside the case. There's a couple different mounting options that it comes with. I'm just going to use screws, and I'm going to mount it. I'm going to mount it as far over towards this edge. So the board is going to be over here. I want to make sure I have enough clearance. So I'm going to mount it as far over towards this edge as I can. I think I'm going to go with something like that right there. All right, made some adjustments, just trying to get my alignment and everything where I think I want it, because I really don't have to pull this thing apart 15 times. But power supply fitting is super simple. There are kind of like tracks here, and it just slides down underneath those. I have to flex the case a little bit, and it pops right in. And then on this side right here, that tab, you can take one of these locking tabs that I printed out, and it just sort of fits over that.
A few moments later.
All right, an issue I'm finding with the case isn't really an issue with the case as much as I wasn't paying attention. These clips are for a different style power supply. The case was redone, and I guess I was just assuming that these clips would fit with the new power supply. They do not. So I'm actually just going to use the power supply mounting holes. I'm going to drill a couple holes in here and attach it that way. Yeah, not bad. We'll take it. Stays put. That's all I care about. It's not going to move around a lot anyway once I have it in its final resting place. And okay, so let's see. Let's talk about this for a minute too. This case, I think, is going to be just fine for what I'm doing. I am not going to be, I'm going to overclock a little bit, and I'm going to do some experimenting, keep an eye on thermals and things like that. But to be honest, the cooling and stuff like that in the back of the case, there's probably some different configurations you could go with. There's certainly different cases out there. There's a ton of different cases, all kinds of things. Things that move USB ports to the front and do all kinds of this and that together. For me, it's not that crucial right now. If I think that this case isn't giving me what I need, not living up to what I really need to have to be successful with it, I'll look at printing something else or going with something else. But honestly, you don't even have to print a case. I mean, you can really just you can put in a regular PC case if you want to, or a secondhand case or anything like that. So you're only limited by your imagination. For me, I think this is going to work good for me. If it doesn't, I'll definitely report back. I'm gonna be doing a lot of little projects with this. We're gonna set this up hopefully as an emulation machine, as a Steam machine, as all kinds of things as we move forward. But for now, I'm going to attempt to slide. So you know that metal plate that's right there that you see on the back of the board, it slides into. If I can show you, it slides into this half of the shell on these rails that are printed in the case right here. So start sliding those in, and then we can make our power connections. We want to do these first. The fan ones are definitely the tighter ones, right? And this one here. We go here. This here. Right, this one might have been the tighter one. Okay, so all right, I'm gonna do the large power connector first because I have more slack there. All right, so we'll do this first. All right, get those plugged in. We do all our cable management down here in the bottom side of this case where there's this gap. All right, and then I gotta start it in. All right, then yep, getting it started. Then I can do the fans here. I can reach the connectors in there. All right. That. And that. Okay. Those are connected. Those are connected. A little cable management here. Well, the best that we can anyway, given the circumstances. And then really, things should just sort of slide together. Nothing to mention there. Oh yeah, there we go. All right. And everything up. It's got those locking clips that printed on the back half of the case. Boom. There we go. I mean, that's pretty slick. I gotta tell you, that is pretty slick. All right, looking back there now, looks like, I'm not sure if you can see it or not. Light in there. So there's plenty of room back there. I'd say there's probably 2 or 3 inches between the back side of this fan and where it fans out. Oh man, that is cool. That is just too awesome. I'm going to, we're gonna stick this right on the front. When all is said and done, have our own little steam machine here, right? But yeah, okay. So my etcher is done. I'm gonna hook everything back up and let's get an operating system installed in this bad boy and move it along. All right, that whole process takes about 15 to 20 minutes. So give yourself a break. Go enjoy yourself, something outside, touch grass. Then once it's all done, we can just click here, exit to live desktop. And this is, remember, the live desktop that we've got here. So if we want it to boot off of the actual hard drive and not the USB disk, we need to restart. So we're going to restart, and I'm going to remove that USB drive so that we actually end up on the in the actual installed OS. All right, and eventually you'll get here to sign in with Steam. Doing the Steam sign in using the mobile app. And there we go. Desktop mode, right? I say power, is that it? Which desktop? Yeah, there we go. All right. Okay, so at its core, we're done. So this, if you wanted to set up a Steam machine, it's set up, it's running. But there's some other pretty awesome things that we're gonna do to this system. We're going to actually unlock some of the compute units in the system because right now it's not using all of them. So the next thing we're going to do is we want to unlock, there's 16 compute units that have basically been harvested or shut off on your blade here. And what we want to do is we want to try to get those back. This is a process that there's kind of a lot going on here. And I'm going to be honest with you, I am not a Linux guru. Most of my Linux-based knowledge goes from, I deal with Linux a little bit at work, but most of it is I need to do a specific thing. I go learn how to do the specific thing, which is great to help me get through the specific thing. It's not great for retention or understanding or anything like that. I have looked at several processes that are out there, and I have found several things that seem to work, and I've done my best to create a guide of what worked for me. Now, the downside is what works for me, which I'm going to walk through it right here with you guys, and hopefully you get the same results and it works for you. If it doesn't work for you, leave a comment. I'm sure there's going to be people watching this video that have a lot more Linux knowledge than I do and can probably comment on some of the things that I'm doing and some of the things that I'm saying, and perhaps I'm incorrect or misunderstand. Like I said, I know this works for me, so now I'm going to give you those steps and hopefully it works for you. If it doesn't, leave a comment. Someone from the community will get in there and we'll see if we can get you figured out, get you straightened out. All right, to start off, we're going to go to my download page. This is the page I'm working on to try to set up a repository for if we use files doing different mods, different builds. It's a place everybody can come to and download, hopefully. These things tend to, links get broken all the time. I hate going to watch an old YouTube video, and of course the links don't work. Things are broken. You gotta kind of like keep going down it. So hopefully this is working. It is fresh and new, so it doesn't have a lot of information in it yet, but we'll get there. All right, BC250. We are going to, this is where the BIOS files are. We are also going to, now we're going to download the Qt unlock. All right, open it up. Okay, right here, we need to extract this. All right, inside here, we have a couple things. We have all the kernel files that we're about to update. We have this user's guide, which I'll go ahead and open that, which again, myself and ChatGPT tried to put together something that was at least legible, readable, understandable. I don't know, any of that works, right? If you have feedback, if you get stuck, please let me know. I can change and modify these files. If something I did isn't correct, let me know that too. All right, first thing we're gonna do is we're gonna make a backup, a restore point basically. So inside the downloads window, I'm gonna open terminal here. And I've already created a restore point, so I'm not gonna create another one, but the command to do that is right here. OS tree admin pin 0. And I can show you here that I have a couple already set up. This one here that's pinned, this is my backup right here. All right. So once you have the backup is great because when you're booting, if you end up corrupting this build, you don't have to reinstall everything. You just go right back to it. It's in the boot menu. It'll show you your different build options, and this one will show up as just a different option. If you haven't been following along with me, you've been sort of like cherry picking the things that you needed for your build, and you already have a GPU governor installed, you need to disable it. You need to turn it off. You need to shut it down. We haven't done that in this build yet, so if you're following along with me, you don't need to worry about step 2. We're actually going to set up the governor after this step, and that was done intentionally, so we wouldn't have to worry about it. But if you do have a governor installed, here's commands for the typical governors that are used. You can shut those down. Once you know your governor is not running and there's no sort of overclocking or anything going on, you want everything pure stock. We need to check to see what your compute units map looks like. So to do that, this script, I actually got this from Old Lamer off of one of his videos. It's awesome. It works really well. Shout out to him. His link's going to be down in the description. So much of what has been developed for this board and this community has come from him, and him working with a lot of other talented developers and people out there. So he definitely deserves so many props for getting this on, because this project would not be where it is without him, for sure. All right. You actually don't have to copy. You can just highlight and hit center click on your mouse. That'll do it. All right, so we changed permissions. Now we are going to execute this script. I think I actually have to sudo this. Do I have to sudo this? No, I don't. Okay, perfect. All right, so here you go. Perfect. This is what you're looking for. All right, I'm gonna scroll down my user guide here. This is what you're looking for. The 16 unused are all grouped together and put off to the side. What people are discovering is that as the board had issues, or perhaps from the factory as it was put out, sometimes different compute units would be, you know, kind of like in this here. You know, these two were working, but maybe there was an issue with this and that. If you have something like this, unfortunately, I'm here to tell you, you're going to have problems. You're going to have to go through a process, and Old Lamer actually details it very well in his video of basically unlocking one compute unit at a time to make sure that none of them are corrupted, or, you know, chances are if it's like this, they were probably done because the compute units are no good. However, you can still unlock all the other ones with it. You just don't want to use this script in here because it's going to unlock them all together. A lot of Old Lamer's video references his GitHub. GitHub's right here. There's some more information on unlocking very specific a CU if you need. For us, we're going to press on. So I'm going to extract this, all the kernels. I'm going to get rid of this other terminal window here. You need to open a terminal window inside of what you just extracted. All right. The terminal window here. And then once you're in the folder with those RPM files, we're going to run this command. Sudo needs your password. And this is going to take a few minutes. The reason for doing this is we need to roll back the kernel to I believe the version is 6.17. It's a little bit older kernel. And oh yeah, you can see it right there in the RPM files window. We need to roll back to that kernel because this script only works with that kernel. I'm sure there's more stuff being developed, but as of the making of this video, this is the cleanest way to do it right now. All right, and when that is finished, now we're going to modify that kernel, or I guess set up those files, those RPM files, to use all 40 of our compute units. At least that's the plan. All right, once that finishes, we have to, hey, just like it says here, we got to do a reboot. Run a reboot command and we'll pick it up after it comes back. All right, back after the reboot, back in your desktop. We're going to open terminal here. Here's a cool little shortcut. You can just push up on the D-pad and that will take you back to your previous commands. Linux does have some cool stuff with it. I'm just gonna, I shouldn't say D-pad, I'm sorry, up arrow on your keyboard. I'm already trying to game, you know? Okay, and then we enter and check it out. Ladies and gentlemen, that is 40 of 40 compute units active. So I hope this worked for you. I hope this got you to this part. I know this is a long video. I really wanted to make a all-inclusive kind of step-by-step guide as to what I did, how I did it, why I did it. So if you're sticking with me, I appreciate it. If you're liking it so far, hit the like button, leave me a comment. If you're new here, the subscribe button helps me out a ton with YouTube's algorithm. So shameless plug for myself. If this is helping you, you know, let me know. Let me know in the comments. If it's not helping you, you know what? Hey, leave me a comment on that too. I think the algorithm doesn't care if it's hate or not. You know, if you think this was the dumbest thing you've ever seen, tell me all about it, baby. I'm here for it. Okay, now what do we got? We've got our system set up. We've got our operating systems installed. We've got all of our compute units unlocked as this board should have been. So right now, as it sits, this thing's already better than a PS5. You know, I know there's a lot of comparisons with this on the PS5 board because it's, you know, pretty much the same thing. Not exactly, but it's very, very similar hardware to what's on a PS5. Well, now we're better than a PS5. So we are rolling here. This next part, I'm going to call it optional. It literally just came out 2 days ago. A couple days ago. Maybe it was yesterday, 2 days ago. Anyway, doesn't matter. Someone has figured out how to unlock the disabled CPU cores on the BC250, which is phenomenal. So it's a user. So on this GitHub page, I'm going to have the link down in the description. If you want to try it, go for it. RWRR0644. You are the GOAT. You are like the third or fourth GOAT we've talked about in this video. This community is phenomenal. The BC250 community is something I have not seen in modding in a very long time. Like, there's a lot of people working on this right now to come together. And you know what's funny? I think I noticed that happens a lot when prices get outrageous. I don't think people want to pay that much money for a Steam machine. They don't want to pay that much money for a PS5. People don't want to pay so much money for these things. Building a PC is outrageous now. You just can't do it anymore. So here we go. Step up the modders. You know, this is where it's at. Something to keep in mind here is this will only work while the system's booted up. You can do soft reboots and it will be persistent. But if you power off your system, you're gonna have to rerun this script one more time. So we will go ahead and run it. All right, the first thing we need to do is we need to get this repository on our system. So we're going to use git clone to do that. Now we need to go into the directory. And we need to give executable function to the Python script. right, and then we need to, if you do have a governor running, you need to kill your governor because it will mess things up. Okay, so as you see, I don't have a governor installed. I haven't set any of that up yet. So we can go ahead and run the script because I changed the permissions on it already. All right, okay, reboot to bring up all 8 cores, 16 threads. This is gonna be awesome. After we've rebooted and we've come back into desktop mode, the last thing I want to show you. So first off, let me do this. Let me go to CPU X here. I want to go ahead and show you that we have all 8 cores running. That's outstanding. So I like CPU X for monitoring, and I also like LACT for monitoring. Let's see, hardware info. There's our 40 compute units unlocked. So everything right now is configured the way I want it. The next thing a lot of people will do is install a governor and get into overclocking. I am not going to get into overclocking yet, and I'm going to show you why. Let me get out of this. I'm going to run up my FurMark software again. And I'm just going to run the test. So running this FurMark test, you know, it's really going to stress, and which, man, 120 FPS is, I mean, this is awesome for what we got. This is even better because we've unlocked those other CPU cores, and I mean, it is great. What is not great is my thermals right now are not running great. And so I've run this for a little bit, and I get up to around 100 C, which is a lot warmer than I want to be. So I think what I'm going to do is, there are some other cases out there. There's some other setups where they actually use multiple fans. They have like a push-pull setup. That's Joe from Rad Junk. He's actually done a push-pull setup, and I'm thinking that his thermals are going to be probably better than mine, because right now I'm just running the 120 millimeter fan and then a couple of 40 mils for an exhaust out the back, and it's just not keeping it as cool as I'd like it to. It's running a little too warm. Now again, we are stressing it to the max, but I have a feeling if I kept this up, you know, it's going to damage something. So I certainly don't want to overclock here right now. If I get my temperatures kind of figured out, and I do a little research and come up with an idea, I'll create a second video documenting what I do to take care of my temperatures, and then also we'll go into a little bit of overclocking and things like that. For now, this is kind of it. We are set up. We have Steam going on. We have everything that we need to enjoy this, and I do think that my thermals would be fine playing games. I want to get in and do some tests on that too. So let's go back to gaming mode here. Well, I would pretty much call that a success. What started as a piece of e-waste destined for a scrap pile has been transformed into a fully functional Steam gaming machine. So along the way, we printed a 3D custom case. We took a look at some of our cooling challenges, updated the BIOS, installed Bazzite, unlocked all 40 GPU compute units, and we unlocked all the CPU cores. This thing is ready to go. I'm going to get some games installed, and I'll be posting some videos of some testing and benchmark with it throughout the coming weeks. I want to really set this up as an emulation machine. I think this will make a really awesome emulation machine. You know, I also want to take a look at the thermal issues that we've had. I want to make sure that we get that under control, and then maybe dabble into some overclocking and see what we can do. I just have to tell you, I think this is awesome. The community that's out there right now and the people that are doing everything for this board and turning into things is pretty awesome. Old Lamer is definitely the GOAT. If there's anything that I didn't cover very well in my videos, he's got a lot of videos out there broken down into sort of the process of, you know, step by step, kind of what has happened throughout the development cycle of this. I wanted to create a video that sort of put everything together and gave you like one giant video of everything that you could do with this. And really this first one is configuring it and setting it up and getting it, you know, getting it built to do anything that you could possibly want to do with it. I mean, this thing is great. Like I said, we're definitely not done experimenting. The system is ready to use, but I want to do a little more performance tuning. I want to try some different games and things like that. I will post specifics if there's things that you want me to test or specific things you want me to try out and maybe compare to the one you're working on. Let me know. Leave me a comment. I will absolutely love to work with some of you guys on seeing, you know, how far we can push this thing. I think sky's the limit with this. We're going to be able to do some really neat things. If there is a specific follow-up you're looking for, let me know. Drop me a comment. I can make a video for that. If this project helped you out, if you're working on one of your own, if it's something you're going to use, or if you're just kind of interested and think it's a neat project, leave me a comment. I would love to get together with some of you guys that are out there doing this on your own as well, and kind of see some of the observations you have and what worked for you, what didn't. If you have a specific case in mind, because I really would like to tackle that thermal issue, let me know. I want to know. So leave me a comment, and thanks you guys for hanging out. I know this was a long one. There was a lot here. If it helped you out, if you liked the video, do all those YouTube things. And thanks for watching. We will see you guys in the next project.